Hello everyone, can you hear me? Hello, my voice is coming? Good evening everyone. My voice is clear to all of you? Hello, can anyone tell me whether I am audible or not? Hello, am I audible? Can anyone unmute and tell me whether am I audible or not?
Yes, sir.
And my screen is visible?
Yes, sir.
Okay, so we will start now. Hello everyone, a very good evening to all. I once again welcome you to the interaction session on NPTEL course Experimental Physics 1, which is being flowed this July 2023 session with course code NOC23 Physics 37. Myself, Vivekananda Nayak, I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So, in the previous interaction session, we had discussed about the moment of inertia related to the experiment that you must have learned, um, which is a measurement of moment of inertia of a flywheel. So, uh, we are solving a few problems related to moment of inertia. Now we'll continue that, and also after that we'll discuss two more experiments. So now first question of today's session is related to that moment of inertia problem. The mass of each ball is 200 gram and they are connected by a cord. The length of the cord is 80 centimeter and the width of the cord is 40 centimeter. What is the moment of inertia of the ball about the axis of rotation? Ignore cord's mass. So this is the question. Now the situation is the mass of each ball is 200 grams and they are connected by a cord. The length of the cord is 80 centimeter and the width of the cord is 40 centimeter. That's the moment of inertia of the ball about the axis of rotation. Basically the situation is we have four balls, two here and two here. They are connected by cords. So the length of the cord is 80 centimeter and the width of the cord is 40 centimeter. What is the moment of inertia of the ball about the axis of rotation? This is the axis of rotation. About this axis, it is being rotating like in this way. The mass, this is m, 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 and this mass is 200 gram. And this distance is 40 centimeter. This distance is 80 centimeter. This is 40 centimeter. So this is the axis. There are four masses. These four masses are connected with the help of a cord. We have to ignore the cord's mass. So what is the moment of inertia about this axis? What is the moment of inertia of the balls about the axis of rotation? This is the axis of rotation. So please calculate and tell me what will be the answer of this situation. I'll give you a few minutes and then we will solve. Yes. Can anyone tell me what will be the moment of inertia of this case? Anyone who has solved it? Let's solve then. So basically we know moment of inertia is defined as summation over I mi and ri square. And this is the case for distinct distribution or discrete mass distribution. So as you can see here, these masses are discrete and the distribution is continuous. So we can directly use this formula. So when you use this formula, then I will be m1 r1 square plus m2 r2 square, like that 4 times, because there are 4 masses and all of them are at same distance from this axis. So if you put here, it will be 4 into m r square. So it will be 4 into m is 200 grams. So it will be 0.2 kg into r square. R is 40 centimeter. Now this is the distance 40 centimeter. So this is r. Distance 40 centimeter, which is 0.4 meter. So it is 0.4 square. So when you solve it, it will be 4 into 0.2 into 0.16. So it will be 0.128 kg into meter square. Answer. So as you can see here, since this mass, since this is the axis of rotation and all these masses are at same distance from that axis, so the moment of inertia is the contribution of moment of inertia for each mass is same, because the for each ball is same because they have same mass and they are placed at same distance. So these are a few things which are important in case of calculating moment of inertia. What is the position of that axis and where the masses are distributed and how the masses are distributed. So this is the answer, 0.182 kg per meter square. So now let's go to the next question. Now this question says the moment of inertia of a body does not depend upon A. Option A is the mass of the body. Option B is the shape of the body. Option C is the axis of rotation of the body. Or option D, angular velocity of the body. Can anyone tell me what will be the answer? The moment of inertia of a body does not depend upon which parameters of a body? Yes. Anyone? So now the question is moment of inertia body. Now moment of inertia is what? Moment of inertia is I is equals to m r square. So it definitely depends upon mass. So mass of the body is, so it depends upon mass of the body. So mass of the body will not be correct answer. And again, the second option is shape of the body. What do we mean by shape of the body? The shape of the body is nothing but the distribution of mass. Suppose this is the shape of the body. So it is circular and this is the axis. So suppose this is the axis. Suppose this same mass is distributed like this. And there is the axis of rotation. So in both the cases, even if the masses are same, suppose here the mass is m and here also the mass is m. But since the distribution mass is different, so the distance and mass will be different for both cases. So the moment of inertia will be different. So also moment of inertia also depends upon the shape of the body. So this is not correct. And also we know the most important factor in moment of inertia is a axis about which we are calculating the moment of inertia. So the axis plays a significant role. Suppose we are calculating moment of inertia here. and or we are calculating moment of inertia here. Suppose we are calculating moment of inertia here. So due to this change in or shift in the axis about which we are calculating the moment of inertia, the value will definitely change according to parallel axis and perpendicular axis theorem. So it again depends upon the axis of rotation of the body, but this is angular velocity of the body. Till now in moment of inertia we have not discussed anything related to angular velocity of the body. So moment of inertia of the body does not depend upon the angular velocity of the body. So this is the correct answer. Now, next question is a flywheel is. So, is there any doubt in this question why the moment of inertia does not depend upon angular velocity of the body? Anyone? Yes? Any doubt? Okay, so then we can proceed to our next question. Now, this question says a flywheel is a uniform disc and its diameter is increased by 1%, keeping the mass same. Increase in its moment of inertia about the central axis is. So, can anyone tell me what will be the increase in moment of inertia if the mass of the uh, disk is same, but its diameter is increased by 1%? Please try and tell me what will be the answer. Otherwise, I will solve it. Yes, can anyone tell me? But if we increase the diameter of a flywheel and we keep the mass same, then what will be the percentage of increase in its moment of inertia about the central axis? basically we have to calculate the change in percentage with respect to the original one. Basically, so here it is given it increased by 1%. So increase by 1% means if dr is the change in its diameter or radius divided by the original radius or diameter, because it's same if the diameter is increased by 1%, the radius will be also increasing by 1% because diameter is directly proportional to radius. So here in the question we are given with dr by r is 1%. So there is an increase of diameter or radius 1% increase, but the mass is same. The mass is same, so delta m is 0. So mass, there is no change in mass, so there is only change in the radius. So we know the moment of inertia is generally directly proportional to r square. So if you take it, then it will be if you integrate it, it will be taking derivative. If you take logarithm on both sides and take derivative, then it will be di by I will be equals to 2r dr divided by r square di by I. So this is 2r dr divided by r square. Like suppose I equals to kr, then ln I will be ln kr. So ln I will be ln k plus ln r. Since this is constant, so its derivative will be this is r square. Suppose so this is r square. So suppose k is constant, so this will be constant. So its derivative will be 0. If you take this derivative, then it will be 1 by I into di, which will equal to 1 by r square into d by dr of r square. And this d by dr of r square is nothing. It is 1 by r square into 2r dr. So this is the relation coming from here. So it will be di by I will be equals to 2 dr by r. So we know this value is 1%. So 2 into 1%. So 2%. So the change in moment of inertia about that central axis, because about the central axis, the moment of inertia is proportional to square of the radius. Since the change in the change in the radius is 1%, so the change in moment of inertia will be 2%. So this will be the correct answer. So have any doubt? Basically, in this question, we are given with that there is a uniform disk and its diameter is increased by 1%, where its mass is kept same. So what will be happening to its moment of inertia? Since we know that moment of inertia is directly proportional to both mass and both radius, but here mass is same, but the radius is changing. So here the change in radius or increase in radius is 1%. So if you compare this relation, then the moment of inertia is directly proportional to r square. So taking log both side and then derivative, then differentiating, we get di by I is equals to 2r dr by r square. So it will be 2 dr by r. So this change in moment of inertia is twice the change in diameter, change in or increase in diameter. So since diameter is, suppose this is the diameter is equal to 2r, so d is proportional to r. So dr by r will be equal to dd by d. So 2 into dr by r, since we are given with dr by r is 1%, so it will be 2 into 1%. This is 2%. So the increase in moment of inertia about the central axis will be 2%. Then let's discuss the next question. The question says a flywheel is making 300 divided by pi revolutions per minute about its axis. If the moment of inertia of the flywheel is 100 kg into meter square, then find out its rotational kinetic energy. consider only rotational motion and ignore any type of friction. So we are given with the revolutions per minute means the frequency. The frequency is 300 divided by pi. Since here you can see that it is pi, so this is frequency. But if there are only 300, then it will be angular frequency. So it's 300 by pi means it is frequency. So you have to multiply 2 pi with it to calculate the actual angular frequency. And then the moment of inertia of the flywheel is 100 kg per meter, 100 kg into meter square. Then find out the rotational kinetic energy. So please solve this question. I will be giving you a few minutes and then I will solve it for you. Yes, anyone has solved it? What will be the angular kinetic energy or rotational kinetic energy? Anyone? So let's solve it since you are not responding. So since a flywheel is making 300 by pi revolutions per minute about its axis. So 300 pi revolutions per minute. So F is 300 divided by pi revolutions per minute. So it will be 300 divided by 60 pi revolutions per second, is not it? Then so it is 300. Sorry, this 300 divided by 60 pi means this is 5 by pi revolution per second. Now we know the angular frequency is given as 2 pi f. So it is 2 pi into 5 by pi. So it is 10. What is the unit of angular frequency? Can anyone tell me? What is the unit of angular frequency? Anyone? I don't know why you are not responding, but everyone must know the angular frequency has a unit of radian per second. But this normal frequency is only per second or revolutions per time. Since revolution has no unit, so it is per second or second inverse. But if the value is given in radian per second, so that means 2 pi is multiplied with frequency because this 2 pi is 2 pi radians. So it is 10 radians per second. So omega is 10 radians per second, and this moment of inertia I is 100 kg into meter square. Now we know in linear motion, what is the expression for kinetic energy? Kinetic energy expression is half mv square. Now when you talk about rotational motion, then we know kinetic energy rotational. Then we know mass plays the same role in linear motion as the role played by moment of inertia is in rotational motion. So this will be I, and this linear velocity will be replaced by angular velocity omega square. So half I omega square is the rotational kinetic energy. So we have all the values, half into 100. Since all are in correct unit, kg into meter square, we don't need to convert anything, into 10 square. So this is 5,000, 10,000, 100 into 100, 10,000, 10,000 divided to 5,000, and the unit is joule. So this is the rotational kinetic energy. So the correct option is option C, that is 5,000 joule. So in this question, we are provided with the frequency of revolution, which is 300 divided by pi revolutions per minute. So since it is in minute, but generally the unit of frequency is per second. So we converted into revolutions per second, which is 300 by 60 pi. And then, so this is 5 by pi revolutions per second. So the angular frequency is 2 pi f, which is 2 pi into 5 by pi, which is 10 radian per second. Then we also, from question, we have the moment of inertia of the flywheel is 100 kg into meter square. So since in linear motion, the kinetic energy is half mv square, and in rotational motion, the role played by moment of inertia is equal to the role played by mass in linear motion. So the rotational motion, the rotational kinetic energy will be half I omega square, where I is the moment of inertia corresponding to mass, and angular velocity, the moment of inertia, which corresponds to linear velocity in linear motion. So since we have all the values, we put the values of I is 100, and then the value of angular frequency omega is 10. So it is 1 by 2 into 100 into 10 square, which is 5000 joules. So the correct answer is 5000 joules. Now, next question. The question, a flywheel is a uniform disc of mass 72 kg and radius 0.5 meter. Calculate its moment of inertia about its axis of rotation. Neglect any type of friction. So, can anyone tell me why, if we, since here it's in question, it is provided that neglect any type of friction. So, if there is friction, then whether there will be change in its kinetic energy or not, or if there is change in kinetic energy, what will happen? Whether it will be decreasing or increasing? Please try this question. In this question, the mass is given and the radius is given. You just need to use the formula for moment of inertia of the flywheel. Also in question, it is given clearly that the flywheel is a uniform disc. So we need to calculate the moment of inertia of a uniform disc, which has mass 72 kg and radius 0.5 meter. So if you know the formula, you can easily calculate. So please just you have to do the multiplication only. So please calculate and tell me what will be the correct answer. Let's solve this question. The question is given, the uniform disc has a mass of 72 kg. So the mass of the disc is 72 kg and the radius r is 0.5 meter. We know the moment of inertia of the uniform disc is given by half m r square. So half into 72 into 0.5 square. So which will be how much? 72. It will be 9 kg into meter square because it's 0.5 means 0.25 into 72 by 2. It is 36 and 36 0.25 is 9 kg per meter square. So the moment of inertia of the flywheel is 9 kg per meter square. Let's solve the next question. Question says a flywheel of diameter 0.1 meter, which is free to rotate about a horizontal axis, has a thin cord attached to its rim. The cord is wound around the rim and to its free end, it attached a mass of 0.20 kg, which hangs vertically. When released, the mass from rest, it descends at a distance of 0.08 meter in 1.6 seconds. Calculate the moment of inertia of the wheel by the equating the potential energy lost to the gain of kinetic energy of the wheel and mass. Ignore any type of friction. So the situation is like that. The experiment you must have studied how we measure the moment of inertia of a flywheel. So this is a flywheel. Suppose this is a rim and there is a flywheel attached here. So this is a flywheel. So this is the horizontal axis, which is free to rotate. So this is the axis. So it is rotating like this. This is the flywheel. And the cord is wound around the rim to its free end and to the free end it is attached a mass of 0.20 kg which hangs vertically. So above this flywheel or along the rim of this flywheel we have a mass which is hang from the wheel like this. Suppose this is a mass. This mass M is this is 0.20 kg. So the mass of 0.20 kg. Suppose this is at rest. Suppose we have this is the case where the mass is at rest. Now the question says when released the mass from rest, it descends a distance of 0.08 meter in 1.6 seconds. So suppose the mass is here at t is equal to 0. So when we release it, or obviously since the mass is connected, so it will come down. So within a time period of t is equal to 1.6 second, it covered a distance of 0.08 meter. Now, since it covered some distance, suppose this is ground. This is ground means suppose this is h equal to 0. Now the body after hanging, it is h equal to 0.08. But when it was at rest, sorry, it covered 0.08. Suppose this is h, then there will be some height here, so it will be, suppose this is this is not 0.0, this is h1, then this will be h1 plus 0.08. So there is a change in height, the height is reduced. So due to this decrease in height, there is decrease in its potential energy, because potential energy, we know potential energy is the energy stored by the body on account of its position above the ground level or above some reference level. So if this is the reference level, the height of the body before we release is greater than the height of the body, it reaches a lower point. So there is decrease in height. Since the potential energy is height proportional to height, so there is also decrease in potential energy. So now we know, according to law of conservation of energy, total energy always remains conserved. Now this change in potential energy is converted into the kinetic energy of this mass, because this mass is falling with some velocity. So this mass is gaining some velocity, and due to which it is gaining some kinetic energy. And also there is, since the rim it attached to the string, so when the mass comes down, it will also rotate. So it will be having some rotational kinetic energy, the flywheel. So here the linear kinetic energy will be of this mass, and the rotational kinetic energy is associated with this flywheel. So this flywheel has rotational kinetic energy, and this mass has linear kinetic energy. So the total decrease in potential energy is balanced by the kinetic energy of this mass and rotational kinetic energy of this flywheel. So from that relation, by equating these two energies, we will calculate the moment of inertia of the wheel. So I explained you the situation. Please put the formula and calculate what will be the moment of inertia of the flywheel from the provided data. I'll give you a few minutes and then we will solve. Yes, anyone has solved it? Yes, anyone who has solved it? So if no, then let's solve it. So basically, as I had explained you, when we release the system, then the mass will fall down due to the acceleration or due to gravity. So due to this acceleration, it will be having some the velocity. So due to that velocity, we have the linear kinetic energy, which is related to this, which is associated with this mass m. And also, since the mass is attached with the help of a string to this rim of the flywheel, then the flywheel will undergo rotation. So due to this rotation, since it has moment of inertia and it is undergoing rotation, so it will be having rotational kinetic energy. So but we don't know the moment of inertia, so we will calculate the moment of inertia from the from equating the two energies, or that is the loss in potential energy to the gain in kinetic energy. So first let's calculate the decrease in potential energy when it comes from a height of 0.08. Sorry, the height is 0.08 meter. Okay, so when you calculate it, so the potential energy lost will be mgh. M is the mass of this small block, which is 0.20 kg. So it is 0.20 into acceleration due to gravity 9.8 into 0. I think it is not 0.0, it is 0.80. So it is 80. 8 and 0, it is 0.80. So when you calculate it, it will be 1.568 joule. So this is the change in its potential energy. Now, due to this potential energy, it will be gaining some kinetic energy. So now, in order to, so if you balance this energy, potential energy will be equal to the kinetic energy of the small mass mv square and the moment of inertia of the flywheel half I omega square. So we know from this information we can calculate v, and from that v we can calculate omega, because v is nothing but r omega. V is r omega. So this velocity v is equals to the velocity of this mass of the mass of the mass of the block which was hanging from the flywheel. So this velocity is r into omega, and r the diameter of the flywheel is also given, which is 0.1 meter. So let's calculate the unknown parameters. So suppose suppose this is the height and the time taken is t. So the distance and time. So initial velocity as 0. Then the velocity after reaching here will be h by t. So the average will be 0 plus v by 2. So the average velocity will be v by 2, which will be h by t. So this is the relation. So it will be v is equals to 2h by t. So velocity is 2h by t. So we calculated the velocity. Now due to this velocity, we can calculate the angular velocity also. So now let the formula is Pe is equals to half mv square plus half I omega square. We know v is equals to r omega. So omega is equals to v by r. So we can put here half mv square plus half I v by r square. So if you take half v square common, it will be m plus I into 1 by r square. So it will be half into, now v is 2h by t. So 2h by t into m plus I by r square. So this is half into 2 into height we know is 0.80, 0.80 divided by square. Time taken is 1.6 second. So this is square. And then mass is 0.2. This is the mass of the small. This is the mass of the small mass. This is the mass of the small block which was hanging. This is 0.2 plus I divided by r is 0.05 square. So if you calculate all this P is nothing but 1.568 joule. So this 1.568 joule is equal to half into this velocity square 2h by t, then m plus I by r square. So if you calculate all these, so please calculate it and verify. We'll be finding 1.568 is equals to 0.1 plus 200 I. Then I will be 7.34 into 10 to the power minus 3 kg into meter square. So this is the moment of inertia. Basically, this is the same way the experiment is performed. So when the mass is falling from some height, so due to this decrease in height, it is losing its potential energy, and this potential energy being converted to kinetic energy of the mass and the flywheel. Since the total energy remains conserved, so the potential energy is reflected in the increase in kinetic energy of the mass which is hanging from the flywheel and the rotational kinetic energy of the flywheel. So we compared both the energies, and as we seen here, as we have seen here, the initial velocity was 0 here. Suppose the velocity v is after reaching this position, the average velocity is 0 plus v by 2. So this v by 2 is h by t, because this is the average velocity, because we are taking the time and t. Then in that case, we will calculate average velocity. This average velocity is v by 2 is equal to h by t. So v is 2h by t. So since v is equals to r omega, we know. So omega is equal to v by r. So in this relation, we put the value of v. So we take half v square common, and then m plus I by r square. So putting all the values, we found that the moment of inertia will be 7.34 into 10 to the power 3 10 to the power minus 3 kg into meter square. So this will be the correct answer, option A. Option A will be the correct answer. So now, is there any doubt in the previous question? Anyone? Okay, so let's discuss our next experiment. The next experiment was measurement of surface tension of the liquid. So I'll be explaining a few things related to the surface tension, and then we'll discuss briefly how the experiment is performed. So basically, we know every system in this universe want to be at highest stability, or it wants to be stable. And stability means the energy is minimum, or the energy of the system is minimum. So we need to provide more energy so that we can break that system and we can disturb that system, or we can make the system unstable. So which is related to the stability of the system. Now so in order to maintain this stability, there is a tendency of the liquids to have minimum surface area, and this is the property of a liquid, because because they want to have minimum energy, so they want to have greater stability. So the force of surface tension arises when the liquid is contact with any other material. So there is a surface of contact. So for example, if we are considering the liquid drop in atmosphere, suppose this is a liquid drop, so this is this surface, suppose this is a sphere, so the surface area will be 4 pi r square. So this 4 pi r square surface is in contact with the air. So according to the law, the liquid have a tendency to have a minimum surface area, and we know for any mass, the minimum surface area is, for any particular volume, the minimum surface area is of a sphere. So since according to the due to the property of surface tension, they want to have or tend to have minimum surface area. So any water drop, if you drop some water, it will be spherical in shape. So now how they are spherical in shape, how the surface effects is coming into the scheme of things, because basically if we know that the water molecules present in a fluid, suppose we are considering water, then the molecules of the water are bonded with each other with van der Waals force. So suppose now this is the case. If you see here, if this is a molecule which is lying inside the region, suppose this is a glass, like this is a bulk molecule and this is a surface molecule. So this is the bulk molecule. So this is the bulk molecule and this molecule is on surface. So now you can see this bulk molecule is in contact with this 6 other molecules. So in order to free this molecule, we need to break these 6 bonds. So we need to provide more energy, so it is more stable. So since this is more stable, we need more energy to break it. But here you can see this, which is at a surface, it is bonded to only 4 other molecules. So as you can see here, these 2 molecules are not here because it is another surface. So generally each molecule is bonded to 6 molecules, but here all those molecules which are on surface, they will be bonded to less than 6 molecules. So their energy will be less. So we need less energy to break these bonds. So the system is quite unstable. So since it depends that the number of molecules which are at surface, they will be having lesser energy when compared to the bulk molecule. So as a result, in order to have a minimum energy or more stability, they tend to have minimum surface area, because the surface area minimum means minimum number of molecules are on the surface. So they will be having minimum disturbances from the bulk property. So it is a result of the cohesive force among the molecules of a liquid. More surface means less stability. That means the same case happens in case of a nucleus, and also if you remember, there is a liquid drop model of the nucleus. So and the nucleus is being compared, where the nucleus has been compared with a liquid drop. So there are different terms of binding energy. So here, so in case of nucleus, the nucleons are bonded with the help of nuclear force. Here, similarly here, the water molecules are bonded, or the molecules of a fluid are bonded with the help of van der Waals force. So mathematically, the force of surface tension divided force per unit length. So in order to have minimum energy, the liquid tend to have minimum surface area. So they will be having maximum stability. So now talking about the experiment. In experiment, what we do, we use the capillarized method. So when we dip the capillary inside a fluid, so due to the force of surface tension, there will be a meniscus forming here. So this will be the liquid shape will be like that. If you zoom this portion, it will be like this. So if this is the force of surface tension, which is normal to the tangent to the surface, then we will be having two components. If this is the theta, then this is t cos theta and this is t sin theta. Now as you can see, this t sin theta and this t sin theta, they will cancel each other. So for each point, the contribution is t cos theta only. So since at each point the contribution is t cos theta, what is the length of the circumference? What is the circumference of the circle? The circle circumference 2 pi r. So the total force due to the surface tension will be 2 pi r into t cos theta. So we can write total force will be 2 pi r into t cos theta. Now this force will be, now all the force is in this direction because these are being cancelled. Now since this is the force in upward direction and they are being balanced, so the remaining force, so another force will be there which must be acting in downward direction. So this is nothing but the weight of the liquid. So it is equal to the weight of liquid, weight is mg. So this m is the total energy, sorry, m is the total mass which is in this liquid above this height, because above away from the environment, this is the height of the liquid which is above the normal water level. So when we balance these two forces, we will be having the value of the surface tension T. So this is the experimental way how to calculate it. So at equilibrium, the weight of the water inside the tube will be balanced by the normal force arising because of the surface tension. So this is the force of the surface tension, and this is the force due to the, this is the weight of the weight is nothing but a force. So this will be m into g. So here we don't know m. So what we do? We calculate 2 pi r into t cos theta is equals to rho g into volume. So this is the, so volume is the volume of the cylinder, which will be pi r square into L, and this meniscus. So if you, this is, suppose this is h, pi r square h, and this value is r. So what we can do, we can calculate, it will be pi r square into h plus r, pi r square into h plus r, and then we can subtract this volume of the semi hemisphere, which is 4 by 3 pi r cube into half. So if you calculate all this, so there is a working formula for the experiment which will be coming. The surface tension T will be equal to rho g r h. This is h here, and this r by 3 from this term, r by 3 h plus r by 3 whole divided by 2. So this is the working formula, and what we are doing, we are measuring the height, this height through so we are measuring the height through the microscope, and then we are calculating the force of surface tension. So now let's discuss a few problems related to that. So as you can see here, so now let's discuss the problem, and in this problem we'll discuss that. So again, so now the question says, if the radius of the capillary tube is increasing, then from the, for the same liquid, the level of the liquid column in capillary tube will what? It will be increasing or decreasing, or it will be remaining unchanged, or it will be overflowing. So now here it is given, consider the angle of contact is 0 degree. So since the angle of contact is 0 degree, so all, so here in this case, then the angle of contact is 0 degree. So there will be, so in previous case this was theta, this was t, so t will be only this t. So we will be having, in place of t cos theta, we will be having t only. So can anyone tell me, because since we have discussed here, the formula is here, and from that, using that formula, we can tell if we decrease the radius of the capillary tube, or if we increase the radius of the, if we increase the radius of the capillary tube, then what will be happening to the height of the liquid inside the capillary tube, height of the liquid column inside that capillary tube. Anyone? So as I have already discussed, so this is 2 pi r into t cos theta. So if you compare it, it will be 2 pi. So it will be 2 pi r cos theta. So from that relation, we can again get 2 t cos theta, which will be equal to h rho g, h rho r g. So this is the formula. Rho is the density, r is the radius of the tube, g is the gravitational acceleration, and h is the height of the tube. Since cos theta in theta is equal to 0, so cos theta will be 1. So it will be 2t equals to rho r g h. So now from this relation, we know h r equal to constant. Suppose for here it is given the for same liquid, so rho is constant, and we know again the gravitational force is also constant. So this will be h r is equal to constant. So when r increases, h will decrease, or when r is decreasing, when r decreases, h will increase. So if the radius of if you use capillary tube of smaller radius, then height will be more, and if you capillary tube of larger radius, height will be less. So now here you can easily see here the radius is more here, so the height is less. So as we go on decreasing the radius, the height is increasing, because as we also, if you simply see here, the force of surface tension is being balanced with the volume of the water. Now if you compare volume, then if the radius is decreasing, so since the surface tension is constant, so the volume of the water will be also constant, because or the mass of the water will be also constant. Since mass is constant and the liquid is same, so density is again constant, so the volume will be varying. So if the radius is small, the volume will be small. So in order to have larger volume of the liquid, the height up to which it rises will be increasing. So it is clear that if you increase the radius of the capillary tube, then the height of the liquid will be increasing, because the liquid have to accommodate the, so since here there are two forces which are being balanced. One is the force due to surface tension, and another is the weight of the liquid. So the weight of the liquid again depends on the mass of the liquid. So as the radius is decreasing, the liquid will rise up to a larger height. So now let's consider next question. This question is, if the surface tension of the water is 7 into 10 to the power minus 2 Newton per meter, then the height to which it rises in a capillary tube of diameter 0.35 is nearly. Now consider the angle of contact is 0, and g is 10 meter per second square, and density of water is rho equal to 10 to the power 3 kg per meter cube. So now this formula, how we are, so in the previous case we use this formula. Now how we can say that this formula we can use, because this is the working formula. Now if we are using capillary tube, then the height of the liquid will be very larger when compared to this r by 3 term, because r will be quite small for a capillary tube. So we can ignore this term in comparison to, so h plus r by 3 is nearly equal to r, h. So if you multiply 2 here, so it will be 2t by rho g r h. So it is 2t equals to rho g r h. So 2t cos theta equal to rho g RH for small radius, or generally capital tube have small radiuses. As we go on increasing, the torn has more importance. So these are the values given here. The surface tension is, as we discussed, that surface tension, the unit of surface tension is force per unit length. So the unit of surface tension Newton per meter. So the surface tension of the water is given 7 into 10 to the minus 2 Newton per meter. Then we need to calculate the height, and the diameter of the tube is 0.35 meter. Also, we have to consider the angle of contact is 0 degree, and G is 10 meter per second square, and the density of water is 10 to the power 3 kg per meter cube. So please calculate and tell me what will be the height of the liquid it rises. Yes, anyone calculated? Basically, we will be using the same formula. Since we ignore theta, so we take the angular point at theta is equal to 0. So the formula is 2t equals to EHR. So we have to calculate H. So H will be 2t divided by rho G R. So T is given, it's 2 into 7 into 10 to the power minus 2 divided by rho is 10 to the power 3 into G is 10 into R is 0.35 mm. So the diameter will be 0.35 by 2, which will be 1.175 into 10 to the power minus 3. So if you put all the values and calculate, H will be coming around 0.08 meter, which is 8 centimeters. So the correct answer is 8 centimeters. So the level of the water inside the capillary tube above the outside water level is 8 centimeters. So now again, if a liquid of specific gravity 1 rises to a height of 5 centimeter in a capillary tube, then another liquid of specific gravity 1.25 will rise to the height of the same capillary tube is what? So it is same type of question. We'll be using again same formula, but here there is change in gravity, change in specific gravity, that is change in density of the two type of liquids. So what will be the change in its height? One height is given, we have to calculate another height. So I'll be giving you a few minutes to try it, and then I will solve it. Anyone tried? So let's solve it. So if a liquid of specific gravity 1 rises to a height of 5 centimeter in a capillary tube, then another liquid of specific gravity 1.25 will rise to the height for same capillary tube. So the radius of the capillary tube is same, but there is change in density since the specific gravity is different. So from the same formula, H is 2t cos theta divided by rho g r. So H is inverse proportional to 1 by rho. So H1 by H2 will be rho 2 by rho 1. Now, N is 1, rho 2 is 1.25, H1 is 5, but is H2. So we need to find out H2 because all these are constant for surface tension because in question surface tension in both cases same. So T is constant, theta is 0 means cos theta is 1, rho is changing only, G is constant, and this R is constant because same capillary tube. So for all these constants, H will be varying inverse proportional to density rho. So H1 by H2 is equals to rho 2 by rho 1. Rho 1 is 1, rho 2 is 1.25, H1 is 5, and we need to find out H2. So 5 by H2 is equals to 1.25 by 1. So 1.25 into H2 will be equal to 5. It will be 5 by 1.25, which is 4 centimeters. So this is the correct answer. So we use the same formula. The formula is H is equal to 2t cos theta by rho gr. Since the surface tension is same and question it is given, consider the angle of contact is 0. So cos theta is 1, G is constant, surface tension is constant in all the cases, and radius of the tube is constant because it is same capillary tube. So due to the change in the density of the liquid inside the capillary tube, the height of the liquid will be liquid inside a capillary tube varies inversely with the density. Then H1 by H2 will be rho 2 by rho 1. Then H2 will be 4 centimeter because H1 is 5 centimeter. The next question, the question says water rises to a height of 8 centimeter in a capillary tube of area of cross section a centimeter square. To what height will water rise in a capillary tube of area of cross section 4 centimeter square? Now this is the formula will be quite same, but in the previous case it was the dependence of density. So there were two types of there are two densities. So there was change in the height, but here there is change in cross section. Cross section means there will be change in what? There will be change in radius of the capillary tube because the cross section of the capillary tube is the cross section is pi r square. So in one case, this pi r square is A, and another case pi r square is 4A. So cross section is changing. That means the radius is changing. So we know the dependence of radius. So we can easily calculate the height of the liquid in the second case, that is the cross section, I think 4A. So please try it and tell me what will be the correct answer out of these four options. Yes, anyone calculated? The formula is same, but the dependence of radius will be considered here. So the formula is T cos theta is equal to H rho G R. So H is inverse proportional to R again. So now pi R1 square is A, pi R2 square is 4A. So if you compare these two, then A1 by A2 is equal to A by 4A. So pi R1 square by pi R2 square is equal to 1 by 4. Pi cancels. So R2 will be square root, that is 2 R1. So is 2 R1. So the height of, so the radius of the capillary tube is twice that of the previous tube. Since H is inverse proportional to 1 by R, so H1, so again, if you use the formula, H1 by H2 will be R1 by R2. So if you calculate, H1 by H2 will be R1 is 1, R2 is 2 R1, so H1 by H2 is 1 by 2. So H will be, so H1 by H2 is 1 by 2, so it will be H by 2. So H by 2 will be the correct answer, because H is inverse proportional to R. Since R is changing to 2R, H will be changing to H by 2. Only then the proportionality will be satisfied. So all these were based on the measurement of viscosity of a liquid, which was measured with the help of a capillary tube or capillarized method, where we balance the two forces. One force is the normal force due to the force of surface tension, another is the force due to the mass of the liquid inside the tube, capillary tube. So now let's discuss the next experiment, which is related to determination of viscosity of a liquid. Now, what is viscosity? Basically, viscosity is the property of liquid, which is a measure of the resistance of that fluid to flow. And if you consider liquid, when a liquid flows, it is believed that liquid consists of different layers which are stacked to one another. Suppose these are the arrows. These arrows are each layer. So when the arrow is in contact with, so suppose this is total liquid. So the liquid layer which is close to the wall, so they have a greater extent of contact to the wall, so the friction is more, so the velocity is less. So at the center of the liquid column, the velocity is maximum. So there is a velocity gradient as we move away from the wall or toward the center. So as we move away from the wall, suppose this is R, at R equal to 0, velocity is maximum, and with increase in R, the velocity decreases. So R, suppose R it is here, R1. So when R is increased from 0 to R1, so this is A. So R is increasing from 0 to A, then this Vm, the maximum velocity will be in decreasing to 0. So as we go on increasing as we go away from the center, the velocity of the liquid layer decreases. So there is a velocity gradient as we move away from the center. So mathematically, viscosity is expressed in terms of coefficient of viscosity, which is called as eta. So this coefficient of viscosity eta is defined as the ratio of viscous force per unit area and the velocity gradient. So the viscous force is again due to the this is a property of a liquid, due to which due to that force it opposes the flow, and due to that we have this viscous force. And suppose this is the cross section area through which the liquid is flowing. Suppose this is the cross section area A, and the liquid is flowing. So there will be the viscous force per unit area and velocity gradient. The negative sign is here because there is a negative velocity gradient, that is when R increases, the velocity decreases. So dv by dr will be negative. So there is a negative sign here, and the unit of viscosity is poise or decapoise we can say. So 1 decapoise is 10 poise, and also viscosity is a inherent or intensive property because it does not depend upon the amount of matter. So viscosity is because viscosity is an intensive property. So now let's talk about the experiment. Now how we perform the experiment. So if you want to calculate the viscosity, we can directly calculate this velocity gradient because it is quite difficult to calculate the velocity gradient. So we'll adapt some other method. So what we will do, we will balance the force here. Like in the previous case, we are balancing there are two forces. One is normal force of force due to surface tension, another the weight of the liquid. So here we will be balancing two forces. Now we know if there is a flow of liquid, then there will be a pressure gradient. Suppose this is the pressure P plus dP, and in another, suppose this is inlet, this is outlet. Since the pressure is low here and pressure is high here, liquid will be flowing from high to low pressure region. So this is the direction of the force due to pressure difference. Now we know there is, due to the property of viscosity, there will be resistance to its flow. So that resistance or that force of viscosity will be acting in opposite direction because the flow is in this direction. The flow is due to pressure difference. So the flow is in one direction due to pressure difference, and its opposite direction there is force due to viscosity. So under steady state condition, these two forces cancel each other. So force due to viscosity plus force due to pressure difference will be 0. So we know what will be the force due to pressure difference. Now we know force is equal to pressure into area. Suppose consider this is the liquid column we have considered, and it has area pi r square. So force will be delta P because the difference in pressure is P plus delta P minus P, which will be delta P. So delta P into pi r square. So the force here will be, so the force due to pressure difference will be pi r square into delta P. So this is one force, and another force arising from pressure, another force arising from viscosity, which we have known eta. So from this relation, we can calculate F is minus into A. This A is this curved area because the surface area, cross section area, the pressure difference is reflected in the cross section area, and the force of viscosity is applied in the curved area or the surface area. So the surface area is 2 pi RL here. So there will be dP by dr into the surface area. The surface area is 2 pi RL, where R is the radius of this liquid column and L is the length. So this total length is L and the radius is R. So this is the liquid column in blue we have considered. So this is the force due to viscosity. So from this, if you put this steady state condition, then we will be finding dV by dr, that is minus dV by dr will be equal to delta P R by 2 eta L. So these two forces when you add with each other. So if you balance these two forces, we will be having dV by dr is equal to delta P R by 2 eta L. So this is one. Then again, if you are calculating, suppose we are calculating V, which is a function R, then V will be at delta P R by 2 eta L into dr integration. So this is the velocity we can calculate in terms of integration. So if you integrate it, it will be r dr, integration r dr. So it will be small r to capital R. So velocity difference. So this is r and this is capital R. So the limit will be from small r to capital R. So it will be delta P divided by 2 eta L into capital R square minus small r square by 2. So this is the value of velocity. Now we can directly calculate the velocity here. So we will be using the method. We'll be collecting. So what we have done in the experiment, we have collected the water and we have measured the rate of flow of water, and the flow of water is generally the flow rate is measured in terms of LPM or liter per minute or mass of the water or volume of water. So here we can take the volume of water flowing for a particular time. So we can take volume of water flowing for a particular time, which is equal to velocity into the area of cross section. So this velocity value we can put here, and if you put all these, we can easily then calculate the viscosity eta. So if you put all these values and solve, we will be having dV by dt, that is change in pressure, change in volume of the water with time, equals to pi del P divided by 8 eta L into r to the power 4. So this was the working formula as you have already studied. So this was the working formula for measurement of how to determine the viscosity of a liquid. So we'll be solving a few problems related to it. So please go through these problems what we have solved today. And in next entire session, we will be solving the problems related to this force related to this and viscosity, determination of viscosity. So is there any doubt in regarding to any issue in today's session? Anyone? Yes, is there any doubt what we have discussed in today's session? Have any doubt? So we can stop then. Then we will be meeting in the next session. We'll be solving a few problems. So thank you all for joining. Good night.